Over the last few weeks, we've been looking at the factored form, and today we'll spend a little bit more time with it, talking about how it connects to the graph, and also looking at factored form that has coefficients in it. So it has, for example, a number in front of the x in the bracket, and how we deal with those. So first of all, a few reminders. First of all, recall that x-intercepts are also called zeros or roots. So I might say x-intercept, I might say root, I might say zeros. Those all mean the exact same thing. It just describes at what x values does your parabola hit the x-axis. And that usually happens twice, but it could happen once if your parabola sits on the x-axis, or it could happen none. You know, if your parabola is sitting above the x-axis and it opens upwards. And the factored form, like this guy down here, it provides you the x-intercepts. You just have to swap the signs. And that's what's nice about the factored form. So we'll do a quick warm-up here. What are the x-intercepts for the following parabola? Okay, x equals 4, right? Swapping my sign. And x equals -7, swapping the sign. Now, let's think about why are we swapping the sign? Why does that work? Well, an x-intercept happens whenever your y value is 0, right? If your y value is 0, then you're sitting on the x-axis somewhere. So what we're trying to figure out here is we're really just plugging in y equals 0 and figuring out what x-intercepts make that equal to 0 as well. What x values make your entire equation equal to 0? Well, these two brackets are multiplying together. So if one of them is 0, 0 times anything is 0. The whole equation is 0. So you only need one bracket to be 0 to have your entire equation being 0. So what you can do is you can actually take that bracket and you can set it equal to 0. So just copy the bracket, x minus 4, set that equal to 0, and then solve it. Okay, so I moved my 4 over, plus 4, moved my 4 over, and I solved it for x, and that gives me the x value that makes this bracket 0. And if that bracket is 0, the entire equation is, and it's an x-intercept. So that's what we're actually doing when we're swapping the sign. Right? The shortcut is, oh, you just switch signs, but what we're really doing is taking that bracket, setting it equal to 0, and solving for x. Same thing down here. We took the bracket, x plus 7, we set it equal to 0, and then we solved for x. Subtract 7 to move it over. There we go. Right, that was kind of hidden before because we were just doing the shortcut, but that's really what we're doing when we're solving for the x-intercepts. Now, in this sort of scenario, I wouldn't worry about writing that. I would just jump right to your answers. But we'll be looking at ones today, I'll scroll down a bit here, that have some coefficients in them, like these guys. And when you have those coefficients, it's because, well, most of the time, it's because you have some sort of fraction as your x-intercept or some sort of decimal number. And in that case, you have to use the solving method. Otherwise, it's a little bit too hard to guess most of the time. All right, so let's try these ones out. All right, so this bracket here, okay, no coefficient, that one's pretty easy. Right, x equals 4, I can just guess that one. Okay, the next one, what is the x-intercept from this bracket here? Well, I might be able to guess it, right? What x value makes that bracket equal to 0? Or what I can do is I can take that bracket and set it equal to 0. Right, I just copied it right down, 2x minus 1 equals 0. And now I'm going to rearrange it for x. So I will add 1 to move it over. Add 1 on both sides. Divide by 2. X equals 1/2. Okay, that's my other x-intercept, right? 1/2 or 0.5. Let's see if it works. If you plugged in 1/2 for your x, you would get 2 times 1/2 is 1. 1 minus 1 is 0. Yeah, that seems to work. So in this case, what that coefficient tells you is that that x-intercept is actually some sort of fraction. It's not a nice number, but that's okay. You can solve it. Just set the bracket equal to 0, rearrange for x. In this case, it's still a pretty standard parabola. It has 2 x-intercepts. So there's really not much different other than the x-intercept is a fraction. In this case, there's nothing out front, so it's positive. We know it opens upwards. Let's plug that into Desmos and see what we get. 2x minus 1 times x minus 4. All right, let's see what we got here. So in this case, it's hitting the x-axis at 4. That was our first x-intercept, and at 0.5, right? 1/2, 0.5. That's our other x-intercept. Nothing out front, so it opens upwards. Let's try the next one out. If you want to, I'll let you pause the video and try it out on your own first, and then we'll check the answer in a second. All right, hopefully you had a chance to try this one out. Let's see what you got. In this case, I know there's coefficients on both, so I will get some sort of fraction for both of them. Let's look at the first one here. Now, what x value makes that bracket 0? It's not easy to guess. So instead, I'm going to take that bracket, set it equal to 0, and rearrange it for x. Plus 7 to move my 7 over. Divide by 2 to move my 2 over. Okay, x equals 7 over 2. That's one of the x-intercepts. If you were graphing that, you might want to actually do that division, right? 7 divided by 2 equals 3.5. So if you want to graph it, sometimes it's worth changing it into a decimal number. So we'll leave that there. The fraction is the preferred answer, right? But if you're graphing, switch it into a decimal as well. All right, what's our other x-intercept? Well, once again, some sort of fraction here. So I take my bracket and I set it equal to 0. And now I need to rearrange for x. All right, I'll subtract my 5 over on both sides. I'll divide by 3. And my next x-intercept is negative 5 over 3. So those are my two x-intercepts. Other than having decimal numbers for our x-intercepts, it's still a regular parabola. It still opens upwards, still has two x-intercepts. If I'm graphing it, I would divide those numbers to turn it into a decimal number, right? And that would be what, negative 1.666 repeated. All right, and let's just double check here. Let's plug this guy into Desmos and see what we get. All right, 3x plus 5, 2x minus 7. Change the scale there. Okay. So there's our parabola. It goes way down there, right? I have to change my scale to go down to negative 40. But what are my x-intercepts? 3.5. Yep, that was one of them, right? 7 over 2 is 3.5. And negative 1.667, right? 66 repeated. That was our negative 5 over 3. Well, yep, it seems to work out. All right, so we can kind of put this all together, right? We've tried graphing out these factored forms before. So let's do one more here, but this time the only difference is that the x-intercepts will be some sort of fraction, right? They won't be a nice whole number. But this process will still be the same. Let's find its factored form, so let's get our x-intercepts. Let's find the axis of symmetry that's halfway in between them. Let's plug that into our equation to get the vertex, and now we have our graph. So similar to what we were doing over the last 2 weeks. Now, I've kind of given you the answer here already, but you can ignore that graph for now. All right, so first one. All right, let's take this bracket and let's set it equal to 0. And then solve it to get our x-intercepts. So 2x minus 9 equals 0. Add the 9 when it moves over, so plus 9 over here. Divide by 2. And my x-intercept is 9 over 2. I need to graph it, so this time I actually did 9 divided by 2 is 4.5. And that gave me one of my x-intercepts, so a red dot at 4.5. All right, let's do the next one. All right, take the next bracket, set it equal to 0. 2x minus 3 equals 0. And solve it for x. So I'll add my 3 over. I'll divide by 2. X equals 3 over 2. Once again, I am graphing it, so I will divide that. 3 divided by 2 is 1.5, and that gives me my second dot. At x equals 1.5. That's my second x-intercept. Okay, so I've mostly graphed it. I know that it's a parabola that opens upwards, and it goes through those 2 points. The last thing I need, though, is what's my vertex, right? How far down do I go? Because I need to find the value for the vertex, that bottom point. All right, so following the same process as we did the other week, if we want our axis of symmetry next, right? That line, the green line that splits our parabola in half. Okay, well, we know that it's halfway in between the x-intercepts. So what do? We take our 2 x-intercepts, we add them together, and divide by 2. And that will give us the halfway point in between them. You also might be able to just figure it out from the graph. So in this case, 4.5 plus 1.5 over 2. That gives me 6 over 2, which is x equals 3. Okay, so I drew my green line on x equals 3. I know that my vertex will be somewhere on that line. That's the line that splits my parabola in half. The last thing I need is the actual y value for it too, though. So we take that x value, we plug it back into our original equation, and that will give us the vertex. Right, so for the vertex, we're going to substitute x equals 3 into the equation, and then solve it. Figure out what's the y value at that point. So I go back to my original equation here, and I'm going to replace x with 3, right, in both spots. So sub x equals 3 into the equation. Okay, so I rewrote my equation, right? 2x minus 3, 2 times 3, right, minus 3. 2x minus 9, 2 times 3 minus 9. And now I need to solve it. BEDMAS tells me simplify the brackets first. Okay, so 2 times 3 is 6, so 6 minus 3. And 2 times 3 is 6 minus 9. Now I can simplify each bracket. 6 minus 3 is 3. 6 minus 9 is negative 3. And y equals negative 9. Okay, so now I know where my vertex is. My vertex is at 3 and negative 9. Okay, 3 and negative 9. Now we can go plot that point. All right, here we are, 3 and negative 9. It's on my axis of symmetry, which is what I expect. Okay, and now we have our 3 points, right? Join them together, we've got our parabola, and we're done. So really the only new thing we've done here is we've just started looking at factored form that has some sort of coefficient. And the only thing that does is it gives you an x-intercept that's some sort of decimal number, some sort of fraction. And you can solve for that x-intercept by taking that bracket, setting it equal to 0, and then rearranging for x.